we are going to find the zeros of this function by factoring. So I'm going to make the equation equal to 0, and then we are going to continue on. So the very first thing you always want to check for is the greatest common factor. So in this situation, there is a common factor. What is it? Hopefully you stopped and paused and you noticed that every single term shares a 5. So we're going to put a 5 on the outside. Also notice that every single term shares an x. So 5x times what would give me x cubed? That's an x squared. 5x times what would give me negative 5x squared? That would be a negative x. 5x times what would give me negative 10x? So that is a negative 2. Then we continue on our factoring journey. Okay, here we need to do our a times c. So we're factoring this guy in the red now, and a is 1. So 1 times negative 2 equals negative 2. So we need the two factors that multiply to negative 2 that add to the middle of negative 1. So you make your list, 1 times negative 2, negative 1 times positive 2, it's going to be 1 and negative 2. So we are going to make our box. The first term goes in the first box, and the negative 2 goes in the diagonal box. And then these two factors that we came up with go in either of the other boxes. We look at our first column is how I start, and I say what is the greatest common factor there? That is an x. So an x times an x is an x squared. An x times what is 1x? That is 1. X times what is negative 2x? That's a negative 2. And double check our bottom, 1 times negative 2 is negative 2. So our complete factorization, don't forget this 5x in the front, is 5x, x plus 1 from the left-hand column, and x minus 2 from the top. Now that we have it factored, we can find those zeros by setting each of these factors equal to 0. Okay, and we're going to solve each one of them. When you solve 5x equals 0, that is 5 times x. We're going to undo that multiplication by division, and 0 divided by anything is just 0. Then we have x equals negative 1, because we're going to subtract 1 from both sides. And finally, x equals positive 2. So graphically, our graph is crossing the x-axis at 0, at negative 1, and at 2. So the graph looks something like that.